Digital image fundamentals. This is the first unit in digital image processing techniques. So in that unit, first we're going to see what is meant by image, what is meant by digital image, what is the meaning of image processing, and what is the use of sampling and quantization. So the basic things we're going to see in this first unit. So this is one sample image. Say what is meant by digital image. So actually a digital image is defined a two-dimensional function f of x comma y, where x and y denote the spatial coordinates and f is called the intensity or gray level at the point of x comma y. So here m number of rows and n number of columns. So the image f of m comma n is represented in terms of rows and columns f of m comma n. So the first row and first column, the pixel intensity value is represented as f of 0 comma 0, a function of x comma y. So the image is defined in terms of two-dimensional with respect to x and y coordinates f of x comma y. So here the last element mth row and the nth column, the last pixel element is f of m minus 1 comma m minus 1. So the rows and columns are represented in terms of matrix, in terms of two dimensional. So this is image. Fundamental steps in digital image processing. Image acquisition. First we identify the problem and capture the image by using image acquisition process and image enhancement. So while capturing the image may be blurred, so to improve the image quality we are using image enhancement techniques. And if image is degraded, we are using restoration techniques and we can able to recover the original image. So the restored image is equal to the original image means the error is less. And color image processing. So here each and every pixel intensity values in terms of RGB intensities are analyzed by using color image processing techniques and wavelet and multi-resolution processing. Then image compression. So to store or to transmit the image to satisfy the bandwidth and capacity, so we are applying image compression techniques. So in that two different compression techniques are there, lossless compression and lossy compression. And one of the image processing techniques is the morphological processing, which is used to improve, zoom the given image, otherwise shrink the given image, zooming and shrinking. So this is a major process in morphological processing. And segmentation, which is used to segregate or separate the object from a given image. For that we are using segmentation techniques. And representation and description, which is used to represent the each features in an object in an image, and describe, it is used to describe the objects of an image. Then object recognition, we are giving label to each and every object in the image. So these are all the fundamental steps in digital image processing. Then image sampling and quantization. So sampling and quantization are the major process which is used to convert analog image into digital image. Sampling, it is a process of digitization of spatial coordinate value. So the pixel intensity values are represented in terms of spatial coordinates. So here the sampling process is used to digitize the spatial coordinate values. And quantization, it is a process of digitization of amplitude or gray level values. So the sampling and quantization, both the techniques are used to convert analog image into digital image. Then one more technique, relations between pixels. So here three different way we can relate the pixels. One is neighbors of a pixel, and another one types of adjacency, and another one distance measure. So neighbors of a pixel, it is classified 4 neighbors of pixel or 8 neighbors of pixel or diagonal neighbors of pixel. 4 neighbors of pixel means n4 of p, diagonal neighbors of pixel are n sub is d of p, and 8 neighbors of pixel are n8 of p. 4 neighbors. So here if the pixel normally it is f of x comma y, so the previous rows and previous columns, so the neighboring pixels of previous rows and the previous columns are considered here. So f of x comma y, so the previous row is x minus 1, um, so x minus 1 comma y. Similarly previous column y minus 1, so x comma y minus 1. Then after x, next row is x plus 1, x plus 1 comma y. Similarly next column y plus 1, so x comma y plus 1. This is for neighbors of pixel. And diagonal neighbors of pixels are diagonally, what are the elements diagonally are there for f of x comma y means x plus 1 comma y plus 1, x plus 1 comma y minus 1, x minus 1 comma y plus 1, x minus 1 comma y minus 1. And 8 neighbors of pixels means it consists of both 4 neighbors of pixels plus 4 diagonals of pixels. So n4 of p plus nd of p. Then types of adjacency. Here 4 adjacency, 8 adjacency and m adjacency. So 2 pixels p and q with the values from b are 4 adjacent if q is in set n4 of p. So it like as the 4 neighbors of pixels and 8 adjacency, 8 neighbors of pixels likewise. Then distance measure. See actually the distance between the two pixels p and q in a given image can be realized by 3 types of measures. One is Euclidean distance. So it is the formula square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. And the city block distance is measured by modulus of x1 minus x2 plus modulus of y1 minus y2. And the chessboard distance is measured by maximum of modulus of x1 minus x2 comma modulus of y1 minus y2.